You have to create a formula.
Yeah. Try and understand what it means, Josie, on this diagram. You're told that the mass of something is 100 kilograms, and then the half-life is 4 hours. And I want to know the mass after 12 hours. So what do?
Create a formula and put it in.
Go on then. Go on. But Chelsea, before you do that, before you do that, what's the mass? Let's say this is 4 here, Chelsea. What's this bit here? What are the coordinates here? Chelsea.
4,
4.
comma 50.
Yeah. Okay. What I want to know, how do I go about answering this question without coming up with the formula? Because coming up with the formula takes a long time.
Repeat that.
So what do I do now, Chelsea?
Create a formula.
No. Well, what's the mass after 8 hours?
Oh, 24.
Why 24?
Wait, no. Let me think. 16.
Why 16?
Because the half-life is 4 hours.
Yeah. So, Chelsea, if you're currently weighing 50 kilograms as a person, and then 4 hours later you lose half of your mass, then what's your mass after 4 hours?
After 4 hours would be 8 hours, right?
Now another 4 hours. What? So you are currently here. You are currently weighing 50 kilograms. 4 hours later, what will your mass be? So imagine this is you.
So 25.
Yeah, 25. After another 4 hours, you're 25, right?
Yeah.
And after 12 hours, what's your mass after 12 hours? So you're now here, Chelsea. What's your mass after 12 hours?
12 and a half.
Yeah, 25 over 2. Yeah, you answer the question without actually coming up with the formula. Because every 4 hours you
So
lose your
it's between 8 to 12.
what?
It's between 8 to 12 hours.
No, I'm asking you what is your mass. So how come your answer is in hours?
Oh,
If
how
I'm
much
asking
mass? 12 and a half. 12.
your mass will be right here, Chelsea. I don't know how to explain this any further, Chelsea, because the half-life of you're going to lose half of your mass after 4 hours. So 4 hours, you're now at 50 kilograms, right? Right here,
Yeah.
right? Another 4 hours, you're going to lose half of your mass, which will be,
Yeah.
25 kilograms. Another 4 hours, you're going to lose half of your mass. You're going to be at 12 and a half. So the answer is 12 and a half. How else?
Okay.
How what? Don't you get it?
I do.
So how come you didn't answer it earlier? Okay.
Oh, I get it now, but I was confused earlier.
Oh, okay. So what's the mass at time equals 0? So this is time in hours. What's the mass at time equals 0? Seriously,
Repeat that.
what's the mass at time equals 0?
100.
Yeah, it's right here. Time equals 0 is 100, right?
Yeah.
But the problem arises when you're trying to find out the mass at let's say 10 hours, right here, because it's in the middle of nowhere. You see, it's easy for you to answer the questions where it's multiples of your half-life, like 8, 12, and so on, right? But it's difficult to answer when it's at like 10 hours. So how do you answer this question?
So that's why you create a formula.
Yeah, you see, these multiples of the half-life is really easy because you can just keep on halving it all the time. But you need a formula to work out at a weird time, like 10.7 hours,
You could have
say.
told me that like 3 lessons ago. Now I get it.
Chelsea, I told you this a million times, man. All right, now what? How do you come up with the formula for it? Don't say I haven't told you how to come up with the formula.
I have the formula memorized.
Well, anyway, come up with a way of doing this. Yeah.
How many hours are we doing?
For the half-life is 4 hours.
No, how many? What were we trying to find?
I want you to come up with the formula for this line, for this graph.
4 hours.
Well, is that the formula? So the formula is y equals 4? Is that what you're saying?
No.
So what's the formula for this graph? The formula is y equals a. But then you need to figure out a and k to fit on this graph. How do you come up with a and k, Chelsea?
Let me think.
Use this point. It's really easy here. Put 0 into the t, and then it must be 100 when time is 0. So you force that onto the equation. Then therefore, it helps you to come up with a and k. Do you get it?
Yes, I'm thinking.
Got that? What are you thinking of? All right, Christmas.
I'm thinking about what do I put it into? I can't remember.
Well, no, there's nothing to remember, Chelsea, because this thing here is really time, isn't it? So you put into the t because that time equals 0, right? So when time equals 0,
Wait, why are we putting 0? Can we put 4 or 8 or 12? Does it matter?
no, it doesn't matter. You're right, but why not use 0?
0 is easier.
0 is the easiest one because this whole block will become what? 1 is 0. When you put 0 into the yeah, it becomes 1, and then 1 times a is just a. So you're trying to force the mass to be 100 there. So a is 100. If you put 100 into here, Chelsea, then at time equals 0, it will force a graph to be at 100. For example, Chelsea, hang on, Chelsea. If you draw a graph of y equals e to the power of x, what does that look like as a graph, Chelsea? Draw it. Is that e to the power of x?
Wrong way.
Is that e to the power of x?
Wrong way. Actually,
What?
I can't remember. 0, 1.
Yeah. And then what happens when I draw this graph? Y equals e to the power minus x.
It flips it.
Will I draw it?
It's the opposite.
Will I draw it? What does opposite mean? Because this is also opposite. Yeah, okay. So now what's the intercept of the graph you've drawn, Sophie?
1.
1, yeah. So if I want, what happens if I want 100? What happens if I want the graph to go through 100? I want it to move from 1 to 100, Chelsea.
You shift it up.
No, well, you stick 100 into here. There. Because this thing here would be 1, and then 1 times 100 would be 100. So it jumps up to 100. No? All right, jump to
Wait. Oh yeah. That's what I meant. Transition.
what? Transistor. What does that mean?
Transitions. Translated it.
Transform it, you mean?
Yes.
Anyway, Chelsea. If you use t equals 0 and try and force a graph to be 100, then it helps you to find out one variable, right? So when t is
Yeah.
0, you force the graph to be 100. So anyway, Chelsea, hang on. So you know the graph is going to be of the form y equals a e to the power minus kt. So go on, try and figure out a and k. What do you do?
You put in 100 into the y, 0 into the t. Solve for k
Write,
first.
write it. Write it. Write it.
Um,
Excuse me.
bless you.
So you're trying to force, when time is 0, the graph must be 100. That's what you're saying. Why are you putting 0 into the k? Yeah, okay. And now what?
Wait, shouldn't there be 100 in front of the a?
No, because earlier we didn't know. We're trying to figure out what number should be a. We don't know what a is yet. We're trying to
Well,
figure
we
it out.
gotta find k first in order to find a.
No, we don't. We can find
Oh.
a first and then k if we want to. Sometimes you have to find k
Oh,
first.
okay.
But now what?
Um, um, a is 100
How do you know that?
because this is just 1.
Yeah. Okay. So now you can put 100 back into our equation. You see your equation now becomes more refined. 100 e to the power minus kt. Can you
Yeah.
see that? Oh, but the thing is, when you have this formula, it will give you a graph looking like this. You know it passes through 100. Zoom out so you can see the graph, Chelsea. Or it could look like this, Chelsea. It passes through 100. All good, but it doesn't match up with our half-life. Can you see our half-life is right there, at 4.
Yeah.
See, Chelsea?
You have to
So
you have to put the 4 into the t.
yeah, and then force the graph to be at 50. Then you can work out the k. Go on, do it.
Wait, force the graph at 50?
Well, I don't know. Work out k now. What do you do? Because you've got to force a graph to pass through this point here so that it fits your half-life. What do you do?
Plug it in.
What?
4.
Yeah. So now work out k. Yeah. And now what? Yeah. And now what? What did you do?
I divided by -4, but then I took out the 1/2.
Well, you divided by -4, so shouldn't it be like this? Hang on. Let me erase this. Natural log of a half divided by -4. And then what did you do? I don't understand where you went from here. What do you do now?
I try to take 1/4 away.
Sorry?
I pulled out the 1/2.
How? Because that's like a function and is trapped inside a block.
I don't know. Take out 1/4.
Where's the 1/4? I don't even see a one. Okay. And then what?
1/2.
Yeah, okay. And then what? Yeah, that's okay. But now what?
And that's k.
Yeah, but it looks really
So then,
ugly,
huh?
Chelsea. This looks really ugly. It is correct, but it looks really ugly. It's just so messy. And then your formula becomes messy. But Chelsea, what's natural log of A divided by natural log of B? What's the natural log
Natural
of
log
A?
of a minus b.
Yeah, so use that to break up this thing here.
What? What?
Use it to break up the 1 and the 2. Chelsea, don't you get it?
What? Oh,
Use
yes. ln 1 minus ln 2.
Okay, can you simplify it anymore?
The ln 1.
What's ln1? Well, if you draw the graph ln for me, what does it look like?
Like this.
No, that's not ln. This is e to the power of x. Looks like this. Ln is the inverse. It's a reflection along the diagonal, which looks like this.
Yeah.
Right? What are the coordinates here?
Where? Oh.
Right here. Speaking to the microphone.
How am I supposed to know where the coordinates are?
Well, what are the coordinates here? What are the coordinates
0,
here?
comma 1.
Yeah, 0, 1.
1, comma 0.
Yeah, it's a reflection. So it must be. So what do you say? How am I supposed to know?
I didn't realize.
Anyway, what's the natural log of 1? Chelsea?
What? What?
What's the natural log of 1? What?
What?
What's the natural log of 1?
1.
Okay, well then, let's translate it.
0, 0.
When I give you a block of natural log of 1, your eyes should zoom to this e, right?
Okay.
E to the power of what gives you 1? Anything to the power of 0.
0.
Yeah, and it's right here. It's right there. The
Said
graph
that.
points to 0. I don't know what else. Look, Chelsea.
I literally said that.
Okay, anyway, tidy this up. Work out, try and make K the subject. Go on. No, it doesn't work like that, Chelsea. Because this is no, Chelsea. This is like one block, and this is like
Oh
another
yeah,
block.
yeah. I see.
This is like a
Mhm.
two puts
Yeah,
inside the function. You can write it like
yes,
this.
yes, 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 yes.
You can write it like this if you want to, right? And then you can push this to the power. You see that? If you want to.
But that looks too different.
Yeah. It looks ugly, but you can do it. And this thing here is really Chelsea. What's 8 to the power of a third? Chelsea.
I'm thinking. Hold on. 2 times 2. Hello.
Yeah. You said you were. Oh yeah, 2. Okay, yeah. So the cube root, isn't it? So really, this is a fourth root. So you can, if you want to, you can actually do this, the fourth root, 2, if you want
Too
to.
ugly.
Okay. Well, we're just going to leave it as this, Chelsea. There. Right, Chelsea? When you work with natural log or log, try and write it, try and think of it in terms of this. If you want to, you can push this up here rather than having natural log of 2 over 4, even though you are allowed. Right?
Okay.
So what's the equation of our formula? Chelsea? So what?
It's let me
What's the
write it.
equation? Because we got to punch into decimals. What's the equation?
I'm writing it. Did you erase A? Because I don't remember it.
A is 100. Okay, cool. So now let's jump to decimals. I'm punching the point 0, 100, 4, 50. Go and jump to decimals, man. Chelsea? All right, punching the point 0, 100, the point. How do you draw a dot at 100? Yeah, and then comma. No, don't do the next one. Comma, and then another point. 4, 50. All right, so your graph has to pass through those 2 points. Can you see that, Chelsea?
Okay.
If you simply do e to the power minus x, go on. E to the power minus x, go on. Yeah, that goes through. What's the intercept of that graph, by the way? Chelsea?
Intercept?
Yeah, what's the intercept of the graph, the blue graph you just drawn?
Intercept is 1.
Yeah, but you should know that, shouldn't you?
I do.
Anyway, stick 100 in front of it.
It's shifted to the right.
No, it drags it up by 100. So therefore, it goes through our point, Chelsea. Oh, wait there. Go to the spanner on the right-hand side, Chelsea. The wrench, as you guys would call it. The wrench. No, on the right, Chelsea. Keep going to the right. Yeah, there's a wrench. Yeah. Go to scale, the x-axis. Do it from 0 to, let's say, 10. Go to the x-axis where it says x-axis. Down, no. X-axis. Where it says x-axis. Click. I want to change the scale, basically, from 0 to 20. How do I do it? From 0 to 20, and I want the y-axis. I want it from 0 to 100. Zero to 100. Scale steps in the x-axis. I want it every 4 hours. In the y-axis, I want it every 10. Every 4 hours. Okay. And why are we in that ugly mold anyway? Anyway, can you see our graph? Our graph goes through 100, which is good, but it doesn't match up with our other point, 4, comma. So how do we get it to pass through?
Put in my formula.
Yeah, go on then.
Do I put it in the same one or separate?
Put in the same one, alter it.
Okay. How do I make this bright again?
Turn off the projector mode.
Where? Oh.
Reverse contrast.
Ew, so bright now. 100e negative.
Why do I always have to do the thinking? Why can't you do it?
Shut up.
Charles? You always force me to
Shut
do
up.
all of it.
Shut up.
Even in your maths exam.
No, never
you.
cheat. I would
I
never
can't
cheat.
believe that. I can't believe that. You're going to have one hell of a time on our WhatsApp group. I'm going to broadcast it to your Auntie Ling.
Okay,
Tell
Auntie Lee will be proud I'm passing. Because she
Oh.
didn't pass.
I told you the answer in your test.
No, you helped me.
I told you the answer. Oh, well, I told you how to do it.
Yeah, what's the problem? Ciao. What did I do?
You didn't even tell me it was a test. I thought I was helping with your homework.
Do.
Why using T? It's really a graph of X and Y, isn't it?
T's right here.
Yeah, but on Desmos doesn't understand T. Desmos only understands X and Y.
Ugh. What did I do?
What?
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 Go on, where's your graph?
Why is it not popping up?
Where's your variable? T.
Oh! Silly me.
No, T, I just told you that.
Silly me.
Yeah, but people are gonna Chelsea, people are gonna think you're natural logging 2T. No, Chelsea, Desmos doesn't understand T.
Beach.
It only Chelsea, Desmos doesn't understand T. It only understands X and Y. Because the graph is X and Y. But with you and me, we use time, T, to represent our situation. But Desmos doesn't understand that. So how do you get Desmos to draw your graph?
Let me think.
Chelsea, instead of using T, you're supposed to use X. Because Desmos doesn't understand T. T is between you and me. It represents time.
Oh.
So everything's the same. Oh, Chelsea, wait.
Wrong.
Desmos is thinking you're natural logging 2x. Put a T in front on top of the 4. Oh, you might as well multiply it to a quarter, Chelsea. It looks ugly at the moment, man. Just multiply it to that.
What?
Yeah, and then fix it accordingly.
What?
Look, jump back to iDrew, Chelsea. Jump back to iDrew.
Wait.
Right, Chelsea? Are you in iDrew?
Wait.
No, it looks too ugly, Chelsea. Look at this, Chelsea. Jump back to iDrew. I'll explain.
Ugh. I got the answer.
Well, Chelsea, you've got this thing here, e to the power minus 1/4 natural log of 2t, right? But Desmos doesn't understand t. Oh, you've got to zoom in, Chelsea. How are you going to see what I'm explaining? So, Chelsea, if you leave it like this, Desmos will think you're multiplying 2t. But really, what's happening is that this is one block, multiplying another block, multiplying another block, right? Why don't you merge these two blocks together so it becomes
T over 4 ln 2.
Yeah, so it looks much neater, and then it really helps your understand. If things are neat, you're less likely to make mistakes. Come
It
on,
is
so you're gonna draw on Desmos. Chelsea, what are you waiting for, man?
Yes, I'm here.
That's it.
Okay. Let's see.
So why isn't it working?
Just wait, I'm not done. Jeez, I have no patience.
Oh man, chop chop! Christmas is approaching, Chelsea. I need Santa to visit me. Come on, get this lesson done.
You can't hurry time up.
Well, you can, because you know you can speed and slow down time.
No,
I've explained this before. You know the
it's
tickle
not
clock.
working.
Why isn't it working? You got to figure it out, Chelsea. First, Chelsea, why is that X there at the end? Because we multiply it to a quarter, didn't we?
When?
Look, Chelsea, if you look at the I drew, right, this block here gets multiplied with a quarter, so it becomes t over 4, right?
Oh, I forgot T represents X. Or X represents T.
Yeah, so why isn't it working now?
Oh my god.
Why isn't it working? Chelsea, that t is supposed to be an x because Desmos doesn't understand t, and
Yeah.
I've t in there.
Beautiful.
But Chelsea, get rid of the brackets because it just litters the
What
place up.
brackets?
The brackets,
Oh.
can you not? Now it goes through there. So now that you've got the formula, what's the mass after 10 hours?
You put 10 into the T.
Yeah.
And then,
Okay, Joe.
then you solve and then you get your answer.
Yeah. Right. Anyway, Chelsea, new question now, Chelsea. We did this last lesson, Chelsea. Why are we doing it again?
Because you suck at teaching.
Okay, how about this, Chelsea? Let's say 2 hours in, you did your experiment and you left your experiment running because you can't measure at time equals 0.
Okay.
You measured it and now its mass is at 100 after 2 hours. Okay. After 10 hours, the mass is 20. Say, what's a half life? So
Repeat.
looking at this graph, Chelsea, it will look something like this.
Question,
Sorry.
repeat the
What?
question, please.
Say that again.
Repeat the question, please.
Yeah, you did an experiment. Okay, so this is your block of metal or whatever. I don't care. Okay. 2 hours into the experiment, you weighed it, and now it's 100 kilograms. Okay, that's 2 hours in.
Okay.
And then 8 hours later, meaning 10 hours in, now it weighs 20 kilograms. What's the half-life of this material? Because it's decaying, isn't it? It's getting lighter and lighter. It's losing its mass. I want to know the half-life of this. How do I work out the half-life? Well, on the graph,
Can you repeat in like a small way?
simpler way, you mean?
Yeah, simpler way.
Okay, that you did some sort of. This is Chelsea here doing some sort of experiment, right? And this is the mass of this is our metal block. Let's just imagine it's a metal block. Okay.
Okay.
The metal block is decaying, meaning it's losing its mass as time goes on, right?
Okay.
Because it has a lot of atoms in here, and I think decay is when you starting to lose these atoms that die. Eventually, the
I
mass
said
gets
simpler way. This is so long.
What? This is simpler. This is a simple way. Well, anyway, your mass is getting smaller and smaller. Do you agree?
Okay.
Okay. 2 hours in, you weighed your mass and it's 100 kilograms, right?
Okay.
Now, the mass is getting smaller and smaller and lower and lower and lower and lower. 10 hours, at time 10, the mass is 20 kilograms because it's getting lighter and lighter. Do you agree?
Okay.
What's the half-life of this thing?
Man, let me think. 2 to 10, 100 to 20. Yeah, 20.
Chelsea, looking at this graph, no matter whatever you want to know, I'm just going to give you the figures. But looking at this graph, how do you go about searching for the half-life of this newfound material of yours? What's the half-life of this material? Looking at this graph, how would you go about
Two and
reading
a
this?
half, about
What? 2.5 hours.
2.5 hours, around about.
2.5 hours. How do you
Around
get?
about.
You could be right, but how do you get to the answer? That's important. How do you get to the answer?
I did 100, all the way to 20. I just kept dividing by 2 until I got 20, or near 20. And how many
No,
times divided by 2? I counted as 1,
no, no,
2,
no,
3 is the half.
Chelsea, that's not how you find a half-life. So imagine you're here, Chelsea, right? Chelsea,
Yeah. Mm-hmm.
what's your mass at the moment?
What's my what?
What's your mass?
100.
100 what? Bananas, oranges? 100 what?
100 kilograms.
Yeah, mass, kilograms is a unit of mass. So Chelsea, if you want to know the half-life, it's basically you are here. You got to ask yourself, how long does it take for me to lose half of my mass? How long does it take for me to lose half of?
2.
So no, Chelsea. At the moment, you're 1 kilograms. So you got to somehow look at 50. 50 is somewhere around here, because that's half of your mass, isn't it? And then you jump to this, Chelsea. Can you see the purple dots?
Yeah.
So on that diagram, what represents your half-life?
What represents my half-life?
Yeah, I want to know the half-life of this material. Looking at this graph, what do I need to look at in order to obtain this half-life figure? How long does it take for you to lose half of your mass? So how do you do that, Chelsea? What is it? What part to answer
4.
that? Why 4? No,
Because
why?
half-life goes by 2 each time.
All right, I'm going to change this number
Wait,
to.
no, it's 4 because since it was 4 and it was 100 kilograms, half of 100 is 50. So then if you double 2, it would be 4.
I'm gonna change this question, Chelsea. Let's say 3 years in. Okay, 3 years in, it weighs 100 kilograms, and 10 years later. Sorry, 10 years at year 10, meaning 7 years later, the mass is 20 kilograms. Okay, what's the half-life? What do I need to look at in this graph for me to obtain the half-life? Chelsea, how would you figure it out? What do I need to look at on this graph to obtain the half-life? Chelsea?
Thinking.
Okay, let me put some scales on here. 1 hour, 1 year, 2 years, 3 years, right?
Okay.
4 years. And I'm not to scale. Hang on, let me try and do my best with scale. Hang on. So let's just say this is 5 here, halfway. Not to scale here. 4, 2, 1, and this is 6, 7, 8, 9, say. Okay? So how do I go about obtaining this half-life? This is not to scale, but you've got to use a diagram to obtain.
I don't know how to do it.
Well,
I
if
need
you're here,
guidance. I need actual help instead of just like pushing me a little bit.
well, all right, Chelsea, if you're here, Chelsea, how long does it take for you to lose half of your mass?
4 hours or
Okay,
4 years.
You could be right, but how did you get that number 4?
Because
Your
half
answer.
of it's 50
Half of
and
it is 50.
3 is 6, so 6 hours.
What? Now you're saying 6 hours. A minute ago you said it's 4 hours. Okay, how do you get the 6?
Did I say 4? Oh,
Yeah.
that was 2.
Okay, well, I'm getting really confused. What's the half-life? What's your answer?
6
6 what?
years.
Okay, so now you need to justify why 6.
Because half-life is half the time. So half the time would be 50.
No, half-life is not half the time, Chelsea. Half-life is what
The time
is the
it takes to
time.
lose half of whatever, yeah?
Yeah.
So if we're losing half of 100, which is 50, we're going to be doubling how many years? So that'll be 6.
No, Chelsea, wait there. The half-life is this bit here, Chelsea.
Huh?
This blue line here. That represents your half-life. You see, you see at 3 hours, Chelsea, you weigh 100 kilograms, right?
Okay.
So how? Sorry, 3 years in, you lose 3 years. You're currently at 100 kilograms, right?
Okay.
How long does it take for you to lose half of your mass? You see, that blue line represents. You said for you to think it's 6 years, Chelsea. It's you doing this. That
Yeah,
bottom.
that's what I'm doing.
You should be looking at the top blue line because you're currently 3 hours in. You're currently at 100 kilograms, right?
Okay.
How long does it take for you to lose half of your mass? Well, 1 year, 2 years, 3 years. It's right there. You should start counting at this.
Yeah, it was 6.
No, you're at a location of 6, but it's actually 3 because you started at 3 hours. You took your measurement at 3.
Oh,
All right,
oh.
6. Then you're going to be up here somewhere. Let's say 200. I don't know. Can you see? You can't start counting at the origin, Chelsea. You have to start counting at this weird 3 years because your
Count from the
experiment,
origin. I thought you meant like
Chelsea, everything's drawn on the
no, I
graph. So
thought you meant like the answer. I didn't know how many steps. I didn't realize you meant how many
okay,
steps.
what would you do to find the half-life then for this experiment? What would you?
Well, since
What?
it started at 3 and not 0,
Yeah.
I would double the amount.
What do you mean double the amount? I
So 3
don't.
plus 3 is 6. Or no, okay, so it didn't. You didn't see it at the origin. You saw it at 3, which means it's 3 half-life because it didn't go. It didn't start from 0. It started from 3.
At 3, you got to imagine, as far as you're concerned,
Yeah.
this whole world here at 3 hours. Okay.
Yeah.
Ignore this here because you didn't take the measurement at time equals 0. So now, if you're, how long does it take from here, from where you are at time 3 hours? How long does it take for you to lose half of your mass? It turns out to be
3
here.
more hours.
Yeah, it's not, the answer is not 6. The answer is this blue length, which is what I've been trying to tell you all along. Is that blue length that represents a half-life? Yeah, you can't take it from the origin. You can't say, oh, it's 6 hours because you took your measurement from here, right? Do you get it, Chelsea? Yay or nay?
I do.
Okay, let me give you a different scenario, man. Okay, so at time equals 0, the mass is 100. Okay.
Okay.
2 hours in, you took the measurement, and it's not to scale here. It's at 90 kilograms. 2 hours in. At 5 hours in, you took the measurement, and it's, I don't know, let's say 60 kilograms. At 7 hours, hang on, Chelsea. Let me just try and draw this to scale. At 5 hours, it's 70 kilograms. All right, Chelsea?
Okay.
At, let's say, 20 hours is at 10 kilograms, not to scale. So what's the half-life of this? So what do you do? How do you work it out now?
So what are you trying to find?
The half-life of this material. So if you're working as a scientist,
Okay.
given this graph, how do you work out the half-life of this material? That's all that you're given. And don't work from the origin, Chelsea, because you don't know the mass at the origin, right? You started taking your reading from 2 hours into the experiment. Do you understand, Chelsea?
Sure.
So right at the start of the experiment, you don't know. 2 hours in, you took the measurement and it's 90 kilograms. And then 5 hours in, you took the measurement again. The mass is 70 kilograms. So you can see it's decaying. And then a massive 20 hours later, the mass is only 10 kilograms. What's the half-life of this? How would you go about doing this, Chelsea? If you're a scientist, what do you look for in order to obtain the half-life? Chelsea?
Okay, so I was seeing if it was 2 hours, but then when I did the math, it's not.
Chelsea, this is what you have to do, Chelsea. Imagine you're here, okay, Chelsea. Do you want to be at A or do you want to be at B?
At A.
Chelsea? Okay, you want to be at A.
Yeah.
Okay, it doesn't matter where you start. So here's the concept of half-life. What's half of 90? How long does it, imagine
30.
you're standing here. How long does it take for
Oh.
you to lose half of the mass?
45.
So yeah, 45. So you got to do your reading. Let's say 45 is around here. Okay, I don't know
Okay.
where. Let's just say 45 is around
Okay.
there. And then let's just say it's 6 hours in. Okay, so what's a half-life?
Half-life 2.
What? No, why? What on this diagram represents a half-life? Can you draw another diagram?
Let me think.
Because you're really after.
4.
How do you get 4?
Okay, so we started at 2, and then with the 90 whatever, and then half of that is 45. So then, how did you get from 2 to 6? You added until you get 6. It's 4.
Exactly. This period here is actually 4 hours, and so you can interpret this information as being, oh, it takes 4 hours for me to lose half of my mass, so the half-life is 4, right? Yay or nay?
Yay.
So it is really this length that you're after. That length there represents the half-life, because that's the amount of time it takes for you to lose half of your mass. Let's say you're not standing at A, but you're standing at B. How would you go about working out, as a scientist, how would you go about using this graph to work out the half-life of this? So now Chelsea is at B. Okay, what would you do now to obtain the half-life? What would you do?
I'm thinking, yeah.
What are you thinking about? White
Okay,
Christmas?
so I know that's. Let me think.
Thinking about White Christmas again?
Yeah.
Well, you shouldn't be thinking about Christmas when you're doing maths, Chelsea.
Alexa, 140 divided by 2.
Come on, Chelsea. What's a half-life? How would you go about figuring out this half-life, given this graph as a scientist? What would you do?
I'm thinking.
What are you thinking about?
Wait, what am I trying to find?
The half-life.
What?
What's the half-life of this material, this mysterious material of ours?
It's at time 0?
Well, you don't know anything about time 0. You are currently here. You do know this, Chelsea. At time equals 5, you're at 70 kilograms.
Yeah.
From this, you can work out the half-life. How do you do it?
I thought it was 4.
What?
I thought it was
No, no,
4.
no, no, no. This is a different scenario. Let's just imagine that we didn't have this 2 thing here. Okay.
Okay.
So now, how do I work out the half-life of this thing? Now, looking at this graph.
You can create a formula.
No, no, just looking at the experiment. So, so the experiment gives us this data here. From this data, how do we work out the half-life? What would you do? Well, Chelsea, all right, let's say you're currently at B. What's your current mass at the moment?
70
Yeah, 70 what? Bananas, oranges, or apples?
kilograms. I don't know.
What?
Kilograms.
Kilograms. So if you want to know the half-life, you got to figure out how much time does it take for me to lose half of my mass. So how do you work that out from this graph?
I don't know.
Right, Chelsea, what's half of your 70 kilograms?
35.
So you want to go down here to 35, to a level of 35. That's half of your mass, isn't it?
Yeah.
35. And then move across. Let's just say you should be reading this time. Let's just say it's, I don't know, 9. Let's just say it's 9 hours. So
Are
how
we
do you?
just guessing how many? Like, we don't
Yeah,
know.
roughly. I just want to know the method you would use in order to work
Oh,
out the half.
I would subtract 9 from 5, so then that would be
Yeah.
3.
So basically,
4.
this is your half life. Can you see that? It
Yeah.
doesn't matter where you start, Chelsea. Let's say you start at C. Hang on. So in an experiment, you can just start at C. I don't know where C is. Let's just say this is C here. So Chelsea is currently at C, right?
Yeah.
And let's say C is currently 40 kilograms. How do I go about working out the half-life of this material from this diagram as an experiment?
Well, half of 40 is 20.
Yeah. So you go down to 20, which will be, let's say, around here, and then read this right here. What do I do now? So let's say you're at,
13.
I don't know, 7 hours in, and it's 40 kilograms. Now what? What do I
Well,
do?
in 20 kilograms, it would be 11 hours.
Okay, let's just say it's 11 hours. Okay.
Yeah. Then you
Okay.
subtract 11 from 7, and that would be 4.
Yeah. So this is your half life, that length. Okay, Chelsea.
Okay.
So now it becomes a lot more difficult to work out the half life of this when it doesn't go through the origin. Sorry, when it doesn't go through at time equals 0. So for example, let's say 7 hours in, it's 40 kilograms. 11 hours, it's 20 kilograms. Hang on. Sorry, let me clear this. It's getting messy. So now, Chelsea, you've got a substance here where 2 hours in is 100 kilograms, and then 20 hours later, it's 10 kilograms. What's a half life? Can you see that, Chelsea?
Yeah, I'm thinking now.
Oh, well, wait, ultimately, to figure this out, Chelsea, you've got to imagine you're standing here.
Okay, well,
And
half
then,
of that is 50.
yeah, 50. And then you basically want to know this amount of
4.
time. Well, the thing is, we don't know this amount of time because our experiment
Okay, so
only
how do
gives
I
us.
find it then?
Yeah, that's why you need the formula y equals a
Oh.
times kt. Your job is to
Oh,
work
so
out.
you were just teaching me how you do it.
Yeah. Okay, so Chelsea, what you do is you've got to force put a 2 into the t, and then
Yeah.
put the 100 into the y, and then also
You
you've got to use
solved
this.
for K?
Yeah, you solve for a and k simultaneously because so you've got to do this, Chelsea. 100 equals a e minus k 2. I'm gonna write 2k instead. Okay.
Okay.
And then for this point here, Chelsea, you've got to force the equation to work for this point as well. So I'm going to put 20 into the t and 10 into the y. So 10 equals a e minus 20k. You see that?
Okay.
You've got to find a and k in such a way that you will satisfy both of these equations simultaneously.
Oh, so then you put it in together.
Yeah. Well,
So then it
anyway,
would be E.
I will send you a video to help you. But what
Alright.
you do is one thing divided by another,
Yeah, I
right?
did it right on the homework, right?
Yeah. Yeah. But you didn't understand it, did you?
Oh no, I didn't.
Anyway, send me the recording of this video, okay, Charles?
Okay.
And I see you on Sunday, okay?
Goodbye.
Hope you enjoyed the lesson. Bye bye.
No. Yes. No.
That's why no one likes you, Charles. All right. See you, Charles.
Bye.
Send me the recording.